Hello students, in this video we will learn how to solve organic chemistry questions in your CIE's papers. Organic chemistry basically it's very easy, but sometimes for students they take a lot of time to understand the basic concept, but actually it's very easy. So let's start this question. A homologous series is a family of organic compounds whose members have same chemical properties. So this is what we need to remember, that all the members of a same homologous series must have similar chemical properties. Give two characteristics that are same for all the members of the homologous series. The first one, that all of them can be represented by same general formula. This is the all represented by same general formula. For example, all the alkanes, they have this general formula, CnH2n plus 2, and all the alkenes, they have general formula CnH2n. And the second characteristic of the member of same homologous series is that they contain same function group. All of them must contain same function group. Same functional group. For example, the first member of alcohol is methanol. Second member of alcohol is ethanol. Both of them have the same function group, that is OH. Let's move to part B. In terms of structure, state how one member of a homologous series differ from the next member of that homologous series. That is the actually number of carbon atoms, or you can say they differ by CH2 unit. For example, let's take the example of alkanes. We have propane and we have butane. Its formula gonna be CH3, CH2, CH3, and butane gonna be CH3, CH2, CH2, CH3. There should be 4 carbon atoms in butane. So let's look at the structure of these two organic compounds, these two alkanes. So what difference you could find between their structure? You can see the butane gonna have one additional CH2 group. So this is what our answer is, that the different members of the same homologous series, they differ by this CH2 group. Let's move to the next question. C part. A, B, C are the organic compounds. A has a molecular formula CnH2n. You can see this is exactly the double, like I mean, we have 12 carbon and we have 24 hydrogens. So we have exactly the double number of hydrogens. So we can see that that's the alkene. B has the name tetradecane. We can see that its name ends at ane. So the name of alkanes also ends at ane. So that's the alkane. So these are the tricks to remember, tricks to understand that which organic compounds they are. C has 3 carbon atoms and is in the homologous series with the general formula CnH2n plus 1 COOH. Name the homologous series. And the third one, as we can see, this one contains a carboxylic group. So this is the carboxylic acid. Let's start writing the name. A is alkene, B is alkane, and C is carboxylic acid. Name C and draw its structure formula. C have 3 carbon atoms. So the one carbon atom is for making carboxylic group. This one. And we need to adjust 2 more carbon atoms. One thing which you should remember about the organic compounds, that the carbon is very important. Each carbon should make four bonds, because carbon belongs to group 4 and it have four valence electrons, so it's gonna make four more bonds to complete its octet. So this is the displayed formula of this compound, and this compound contains three carbon, one, carbon 2, and carbon 3. So the name of this carbon, okay, let me tell you about the naming of organic compound, how we name them. You should remember that name of any organic compound must contain two parts. The first one, prefix. So the prefix of the organic compound, it must be depending upon the number of carbon atoms present in that compound. For example, look at this example. Here we have three carbon atoms, so the first part of name gonna be prop, and then suffix of this name, I mean the last part of the name, it gonna depends upon the functional group, the type of functional group. Here we can see that this compound contain carboxylic functional group. So then, and we also know that we use this suffix for for carboxylic acids, so its name gonna be propanoic acid. Next, amino acids are a homologous series where each member has the general structure shown in the figure. The R side chain contains carbon and hydrogen only, this side chain. An amino acid have a relative molecular mass of 103. This amino acid contains a relative mass of 103. Deduce the formula for. So you can do it very easily. You can just minus all the the mass of all of this thing from the total mass. So the total we have 103. So let's start minus this hydrogen 1, minus this nitrogen 14, then another hydrogen 1, minus another hydrogen 1, then carbon 12, minus carbon 12, minus oxygen 16, minus another oxygen 16, minus last hydrogen 1. So it gonna be 29. So now we need to find out what is the like alkyl radical whose atomic mass is 29. So the first alkyl radical is methyl. So we can see that its atomic mass is 17, so it can't be this one. And the second alkyl group is ethyl. So its mass is 12 plus 12 plus 5, so it's 29. So the name of the group is ethyl. Second part, actually it's the last part. State the name given to the natural polyamide formed from the amino acid monomers. We know they are proteins. So that was about the organic chemistry questions. I hope you have understood these things.